Okay, we are continuing talking about programming with arrays, 7.3 of Savitch 10th edition. And the third part on 7.3, we're talking about sorting. Why do we talk about sorting? So when we are searching, of course, there is lots of different sorting and searching. So if I'm just doing a searching and I'm doing searching from the beginning to the end to find something, you will learn how to find the efficiency of these things. So you will have it in your advanced course and in your software engineering to find the cost. The cost for our programs are the CPU time. How much of the CPU time is going to take to do this one versus the other one, or we can calculate how much of a statement needs to be executed. So, for example, if I'm doing the search from the beginning to the end, that's called linear search. It may be the first one, I find it right away, or it might be the last one. So in average, I have to spend half of my size to find something. So if I have 100 elements, I'm looking for something. If it's the first one, that's 1. If it's the last one, that's index 99 or 100. So I add this thing together and divide it by half. In average, I need 50 visits to find something. Now, if we do sorting, and I'm still using this, remember, we have different algorithms. So if my array is sorted already, then I don't really need to check every element to know if I can find this element in this array or not. So we're going to be talking about some of them here. And of course, moving on to your, excuse me, moving on to your other classes. If you're a computer science student, you will learn how to find the efficiency of these things. So if we have an array like this originally, then we can potentially sort it, and the sorted one is going to look like this. So in this way, it's going to be in ascending order. So my smallest one is at the beginning, my larger one is at the end. Now, when we have a sorted function, the cost for it is what? To sort it at the beginning. Then my search is going to be faster. But if we are adding and deleting elements to a sorted array, it's going to cost us more. We don't need to talk about it here. Maybe your advanced class can talk about it. But those are the things that we have to think about it. If I have an array that we are writing and reading too many times, modifying, deleting, inserting inside the array, maybe the sorting one is going to cost us more than what we can save in the searching one. These are the things that you guys are going to be talking about it in your future classes. So now, for example, in this case, if I'm looking for number 33, when I hit the index 1 and I see 35 in there, I know 33 is not going to be in this anymore because it's sorted. Then I stop right there. I don't have to move on. Okay, we're going to talk about selection sort. So selection sort is going to be like any other sort, is going to have everything in ascending order. We can change it to be descending if we want to. So that means we're going to go through the whole array to do this part. And we're going to go create an algorithm, a design of how we're going to do this sorting. So we're going to go through the whole array. We're going to find the smallest element in our array, and we're going to put it on the first element. So we start with index 0. We're going to go find the smallest one. We're going to put it in index 0. Then we go to the next one, and so on. So we need to find, let me be sure that, okay, I got that. Okay. So we are looking for the smallest value in the array. We're going to put it on the first element. Then we're going to go to the second element. We find the smallest one from that point on. Remember, we don't want to include the first one because that would be always the smallest one. So when I put the smallest one in 0, I want to go to the next one. When I find the smallest one, I swap it. That means my second smallest one is going to go to index 1, and so on and so forth. So when we are writing functions, when we are spending time in the design and we are thinking about this, it's okay, if I want to do this sort function, I'm going to need some other functions to be able to do this. So we don't put everything in one function. We call those helper functions. So if I want to write this sort function, selection sort, what other functions do I need? What are my helper functions? What are my helper functions? So if you look at this, I'm going to need a function to find the smallest one. I also need a function for swap. So when I find the smallest one, I have to swap it with the one that I am on at this time. So if it was index 0, we want to swap. So let's go over this to see how does the selection sort works, and then we can write the code for it. So some people like myself are visual people, and we want to look at the picture, create a picture for us to visualize it, to see how does it work. So in this case, we are at index 0. We're going to go look at the smallest value in the array, which is going to be 2, and that 2 is index 3. So we're going to be swapping the value in index 3 with index 0. So the 2 is going to go here, and 8 is going to go there. We just swap. Now that we got the 2 here, we're going to move on to the next one. Then right now, my index is 1. I'm going to be looking for the smallest value from this point on. And then I found 4 in index 5. Now I'm swapping this. So you can see that selection sort, as you're moving forward, the partial of your array is already sorted. The other one is not sorted. Now, one of the concerns that we always have is we want to be sure that we are not going to fall off the array, end of the array. So we got to be careful of what's going to happen when we're getting close to the end. If I have a loop that goes from index 0 to index 9, what is the next thing I'm doing? I am searching for the smallest one that's going to start after it. And if I'm right here, I'm going to start for a smaller one after it. I'm going to fall off. I'm going to consider that. I'm going to be careful with that. So I always start in the middle, and then I check the boundaries. If I'm going to left, we can have our array to move toward left. Then I have to be sure I'm not going to fall off the beginning of the array. That means my index is not going to be -1. If I'm moving to the right, I want to be sure I'm not going to fall off to the right of the array. Okay, so that would be the declaration. You can look at it in your book, and this is the way we're going to be calling it. What else I want to say about this? Let's go back to this one. And yeah. So my sort is right here. So that's my sort on the top right here. We are starting with the index 0. We go to less than number used -1. So we don't go all the way to the end. We're going to stop 1 before the end. So if our last index is 9, my size is 10, then 9 is my last index. I'm going to go to 8. Of course, we are going to be using number used. We are not going to go through the whole array. We're just going to go through the numbers that we have. Then we're going to call our helper function. One of the helper function is to find the smallest one. For us to be able to find the smallest one, I need my array, and I need to know where to start. Because if I start from the beginning all the time, I'm going to get the same smallest number. So I'm going to have the starting point and, of course, the ending point. Then I'm going to call another helper function, that's swap. We're going to swap these two values. So we're going to swap the value of a index, which can be 0, 1, 2, 3, 4, and the one for the smallest one. So that would be my sort with my helper functions. Now, how do we do the swap? So basically, we're going to take this value, we're going to create a temp, we're going to put one of the values in the temp, we put the second one in the first one, and we're going to put the temp on the second one. If we didn't have the temp, then we would overwrite our first value, then we wouldn't have it. How do we find the smallest one? So we're going to start from an index, that not necessarily 0 all the time, and we go to the end of this. So like any other things that we were doing so far for our arrays, we would use a for loop to go through all the elements that we want to go through it. But instead of starting with 0, we're going to start with start index plus 1. That's why we want to be sure here we don't go to the end of our array, because we are using a start index plus 1. So if I get to end of the array and I try to go to next one, remember, C++ is not going to complain. It's just going to go there and give you some weird numbers. Then we're going to check it to see if let me back up. So we did this already. So we're going to put the minimum. We're going to put the first element into the minimum. We're going to keep track of our index of the minimum. And then as we go through this, if what we are going to is less than our minimum, then we're going to set the minimum to that. And then we're going to return the index of that minimum. These are my two helper functions. There is another one that's called bubble sort. So the way that bubble sort works is it looks at two elements and it's looking for the larger one, and it's going to put the larger one of the two to the right. And it's going to keep doing it all the way through the list. and then it's going to come back and do it again, and it's going to come back and do it again. It's the least efficient way of sorting, but that's what it is. So in this case, it looks at 3 and 10. 10 is greater, so it's not going to do anything. It's looking at 10 and 9. 10 is greater than 9. It's swap it. Then it's going to look at the 10 and 2. 10 is greater than 2. Then it's swap it. Then it's going to be looking at 5 and 10. It's going to have 10 more than 5. It's going to swap it, and 10 is going to go at the end. Then it's going to go back and do it again. So that's the question that I want to ask you. I'm not going to go through the code on this. You can look at it in your book. Now, when you put your screen in pause and take a look at this and see if you can get this done before you go to the next section, that would be a good thing, good practice. And we try to do this in the class, go over it together.